Okay, we're going to look at using the debugger features of Visual Studio today. So far, we've been using the compiler to find most of our mistakes, any compile time mistakes, and then any logic mistakes we've been just finding by running our program and then following through the program line by line in our heads. Which is great, and it's a good way to find your mistakes and often a good way to learn about your mistakes. But sometimes it's a little difficult, especially as programs become more complex. So all modern development environments support a symbolic debugging set of tools, and Visual Studio is no exception. Now, what a symbolic debugger lets you do is it lets you run your program and then stop it wherever you want. And once you stop it, you can look at, examine various values. Often you can even change values to see if that changes how your program runs. And you can also, once you've stopped it, you can run it one step at a time and just see exactly what's going on in your program. So if you're trying to debug it, that's very, very useful to be able to just go through step by step by step and watch how the variables change and see how the conditional statements evaluate. So I have here a very simple program with a couple of bugs in it. It's a while loop that finishes when the user enters -1. So just like what we've been doing with a lot of our programs, it has a sentinel value of -1. And then it just asks the user for a number. And it simply compares that number to 5. It tells you if the number is equal to 5, or if it's bigger than 5, or if it's smaller than 5. But it's not working. Let's have a look. First, we'll just run it. So I'm going to do our regular start without debugging. So I'm running the program, but I'm not debugging it. And I'll enter 73. And it says my number is 5. No, it's not. 42. Still says my number is 5. All right, so I'm going to quit. -1 to finish. Oh, and it's not even finishing when I enter -1. Isn't that terrible? I'll have to click on the red X. So I have several problems here. I'm not sure what's going on. I'm going to use the debugger. So the first thing is I have to tell it where I want it to stop. And the way I do that is by setting a breakpoint. And all a breakpoint is I specify a place in the program where I want the debugger to stop execution so I can examine what's going on. And then from that point on, I can single step. So I'm going to put my breakpoint just after the while loop. I'm going to put it after I ask for user input. And the way we insert breakpoints, there's a space here called a gutter. And anywhere along there, if I click, I get this red dot appears. And that red dot symbolizes a breakpoint at that location. So when I run this under the debugger now, what's going to happen is the program's going to run normally until it comes to that red dot, and then it's going to stop. Now I can have multiple red dots. I could put a few breakpoints in if I want. There's no limit. And if you get more advanced, you can even have conditions on your breakpoints. So you could say stop here only if X is bigger than Y. That's beyond what we're going to do today. I'm going to set this breakpoint. So now I'm going to run the program. Now this time we start with debugging. I'm using breakpoints and single step. I'm using the features of the debugger. I want to start it with debugging. So I'll go ahead and click that. And some stuff pops and clicks, and I have a yellow arrow sitting on my breakpoint. So the yellow arrow shows what the next line that's going to be executed is. So the program has run to that spot and is now stopped right there. Now, there's a couple of things to talk about here. Down at the bottom, I have this area that tells me what all of the variables that are currently in scope and their values are. So I can see there's user input, and it's set to 0, which makes sense because I created it and initialized it just before the while loop, and I initialized it to the value 0. Okay, so let's take some steps. So I can step through this program. There's 3 buttons I use for stepping. There's step into, step over, and step out of. And they're those symbolically displayed with a blue arrow stepping into some code, stepping over some code, and stepping out of some code. And what they mean, mostly we're going to use step over, but if there's a function call and I want to go inside that function and see what happens inside that function, I would use step in. So the next line that's going to be executed here is a printf statement. And we've learned in class, printf is a function call. I'm calling a standard library function. And so if I were to click on step into, I would go in there and see how printf works. My bug is probably not in printf. You know, those printf and scanf, those are standard library functions. They're pretty well tested and very thoroughly tested and used by everybody. So I doubt if my bug is in there. But just to see how step into works, let's go ahead and do that. So I'm going to click step into, and we're going to go into the printf function. And you can see it's opened this file, printf.c. There's a little lock on it. That's not a file I can change. It belongs to the system library. And I can step through that a little bit. I don't want to because this is all stuff that's not relevant to my program, but I do want to show you that we can jump into this printf program, and I want to show you how to get out if you get in there by mistake. So the way to get out is this jump out of code, step out. And out we go, and we're back to our own program, and we haven't finished executing printf yet. So I'm going to do this step over. Okay, and if we go back and look at our console, we can see it has done the printf, and it's giving that message, enter a number that printf printed. We haven't done the scanf yet, though. So I'll go ahead and do step over, and now it's going to run the scanf. So it's asking for a number. I'll enter 73, and you can see it's completed the scanf. The yellow arrow is now pointing at that if statement. And when I hit the step button to take the next step, it'll execute that if statement. But let's go down and look at the values of our variables. So we have user input is 73, exactly what I entered. That's what I expect, what it should be. The other way I can look at a contents of a variable is to just hover my cursor over it, and I can see I get a tooltip, user input 73. So this if statement is going to compare 73 to 5. It should be not equal, right? So I should skip down to this else clause. Let's see if that happens. So again, I'm going to click step over. That's going to execute that conditional statement. And the arrow now is pointing inside our if clause, which means this conditional statement evaluated to true. We're in the true section of the if. So let's go down and look at our variable values. Maybe that'll give us a hint. User input is no longer 73. It's been changed to 5. If I hover over user input, I get a tooltip 5. Okay, so what's happened? The light goes on. I have a single equals sign here. I should have a double equals sign. Single equals sign is assignment. I've assigned the value 5 to user input. And so I haven't compared them. And then 5 evaluates to true because any non-zero value is true in Boolean logic in C. So I'm going to fix it right now. I'm just going to put an equal sign there. That should fix our first problem. I could carry on debugging, but once I fix a problem, I like to rebuild, and because I don't know how that's going to affect the rest of my program. It's probably best just to stop and rebuild and try it again. So we've got these stop and play buttons. If I want to just continue execution, I can hit the play button. Now I have a breakpoint set, so it's going to continue until it hits that breakpoint, and then continue until it hits that breakpoint. I'm happy just to stop here, so I'm going to click the stop button. That's going to end the program. I'm going to click build to rebuild my solution. And now that mistake is fixed. So I'm going to run it without debuggered first, just to quickly see if it's fixed. So I'll run my test, enter a number, 73. Your number is smaller than 5. Oh, 73 is not smaller. Let's try 3. Your number is bigger than 5. So I still have a problem. I'll enter -1 to finish, and press any key to continue. I still have a problem. I think I'm going to move my breakpoint to after the printf scanf, because those are working. So I'm going to run the program, and I'm going to stop just before that if clause, because there's still something in those conditional statements that's not working. Debug, again, start debugging, not start without debugging, start debugging. If I want to stop at breakpoints and use the features of the debugger, I have to use start debugging. Okay, so it's enter a number, so I will enter 73 and return. The breakpoint came after the printf and scanf, that's why it popped up right away for me. And now I've stopped at this conditional statement. Let's see, user input is 73, and I look down in my collection of variables that are being watched, and user input is 73. I'm going to step over, and this time I step over the true clause, so this has evaluated to false. I'm not going to say that 5 is your number. Instead, I'm doing this else clause, so I'm going to say if user input, which is 73, is greater than 5, okay, so 73 greater than 5, that's true. I should do this clause. Let's step in and see if that's where we go. It is. So this evaluates correctly. User input is greater than 5. And I do this printf statement. And I'm going to print your number is smaller than 5. Okay, so that's my mistake. I've mixed up my two print statements. I can fix that by switching the print statements around, or I can just switch this conditional around. So I'm going to change that to user input is less than 5. I'm going to stop my debugger and rebuild my solution. And I'm going to run it without debugging this time. I don't want to stop at my breakpoint and step through. I just want to see if I've caught all my problems. So 12 is bigger than 5, 3 is smaller than 5, 73, 42. Everything works, -1, and I exit. That's perfect. So that's a first look at using the debugger. We've seen that we can insert breakpoints to force it to stop. We can put multiple breakpoints. We can, once it's stopped, check out the values. We can then, from that point on, either single step or press continue, and it'll go on to the next breakpoint. And we can look at what the values of all of our variables that are in scope at that breakpoint are. So that's a really useful tool if you've got your program running and it's making some, it's behaving in a way you don't expect. It lets you actually go in, step through it step by step, see what the values are being set to, and you usually very quickly understand the behavior of your program once you start looking at it in the debugger. Okay, and that's our movie for today.